Welcome, folks, to our April 2025 general meeting of the Central Florida Astronomical Society. Thank you for joining us tonight. As always, I am your president, Frank Kane, with you for the first half of the meeting. And if you are watching this and you're not yet a member of CFAS somehow, well, you should fix that. Why would you want to join CFAS? Well, you'll get access to our private events and dark sky viewing locations like the Geneva Range, where we do a lot of events when weather permits. You'll have access to our Loaner Telescope program, where we lend out telescopes for people who might be new to the field and get your feet wet with exploring the night sky. We also have our online community through Groups.io, where we all talk shop with each other, and quarterly meetings at the Seminole State Planetarium, which is about the coolest venue for an astronomy club you could imagine. Your membership also includes Astronomical League membership and access to their observing challenges and their quarterly magazine. And remember, we're a nonprofit 501c3 organization, completely volunteer powered, so every penny of your dues goes toward our mission. You also get discounts on astronomy and Sky and Telescope magazine. Great way to stay up in touch. And if you're interested, check us out at cfas.org. Tonight, we have a very special guest. Professor Avi Loeb is joining us. He's the director of the Institute for Theory and Computation at Harvard University, among many other things, which I'll talk about in a second. He's going to be talking on the search for interstellar objects of technological origin. And we're going to have some Q&A at the end as well. After that, I'm going to pass the baton to our Vice President, Sharife Gacel, who will cover club news and run our astrophotography showcase because I have to skedaddle after our main speaker. So with that, let me give a bio of our main speaker tonight, Avi Loeb. Abraham Avi Loeb is the Frank B. Baird Jr. Professor of Science at Harvard University and a best-selling author in the list of the New York Times, Wall Street Journal, Publishers Weekly, Die Zeit, Der Spiegel, L'Express, and more. He received a PhD in physics from the Hebrew University of Jerusalem in Israel at age 24, led the first international project supported by the Strategic Defense Initiative back in the 80s, and was subsequently a long-term member of the Institute for Advanced Study at Princeton. Loeb has written 8 books, including most recently Extraterrestrial, got my copy here, and Interstellar, got my copy here, and nearly 1,000 papers on a wide range of topics, including black holes, the first stars, the search for extraterrestrial life, and the future of the universe. Loeb is the director of the Institute for Theory and Computation within the Harvard-Smithsonian Center for Astrophysics, and also serves as the head of the Galileo Project. I think we're going to hear more about that in a minute. He had been the longest-serving chair of Harvard's Department of Astronomy and the founding director of Harvard's Black Hole Initiative. He is an elected fellow of the American Academy of Arts and Sciences, the American Physical Society, and the International Academy of Astronautics. Loeb is a former member of the President's Council of Advisors on Science and Technology at the White House, a former chair of the Board of Physics and Astronomy of the National Academies, and a current member of the Advisory Board for Einstein Visualize the Impossible of the Hebrew University. He chaired the advisory committee for the Breakthrough Starshot Initiative and served as the science theory director for all initiatives of the Breakthrough Prize Foundation. In 2012, Time magazine selected Loeb as one of the 25 most influential people in space. And in 2020, Loeb was selected among the 14 most inspiring Israelis of the last decade. In 2024, Loeb was ranked number 3 in publication record and impact of research among all astronomers worldwide over the past 5 years by Scholar GPS. Loeb's latest TED Talk was among the top 5 most popular TED Talks in 2024. That's a lot of stuff, and it's all incredible. And before we get started, just a little bit of housekeeping. If you do have questions for Dr. Loeb, go ahead and queue those up in the meeting chat there, and we'll pick as many as we can get to at the end. And do remember to stay on mute if you would, if you're joining us live. With that, allow me to hand it over to Dr. Loeb. Thank you so much for sharing your time with us tonight.
Thank you so much, Frank. It's a great pleasure to join you. And we will turn into a conversation where you can ask your questions. And I will present for about 30 minutes. It is meant only to give you an introduction as to what I'm doing right now. And I would very much appreciate the conversation later on. So let me share my screen and open my presentation. So this is the cover of a New York Times Magazine article that came out a couple of years ago. And I will try to address the question raised in the title of this article. I wouldn't call myself Hellion hunter because, I'm not trying to hunt any specific biological creature out there, but I'm definitely very curious about whether there is a neighbor that is perhaps even smarter than us in our cosmic neighborhood. And Obviously, science is better than politics because it is based on evidence, not on opinions. And the other thing to keep in mind is the sky is not classified. We don't need to wait for the US government to tell us what lies beyond the solar system. We can collect the evidence ourselves. And if we find any aliens out there, other civilizations on exoplanets around other stars, they would play a very important role because they could potentially be better role models than our politicians. Enrico Fermi, a very distinguished physicist, asked about 70 years ago, where is everybody? And that was during lunch in Los Alamos. And this is a question that has been raised by a lot of lonely people in the past. And what you tell a lonely person is, don't be so presumptuous. You are not that attractive. You have to be proactive. At the very least, you need to look through the window of your home and check if there are any partners out there, or perhaps even go to dating sites. And Enrico Fermi didn't even build a telescope. He assumed that if there is anybody out there, they will come and join him for lunch. But one thing to keep in mind is the scale of even the Milky Way galaxy is tens of thousands of light years. It's huge. Space is huge, and humanity is not that attractive that we will definitely see them visiting us just looking around. Now, people often make this argument that extraordinary claims require extraordinary evidence. Well, first of all, imagining something like us out there on analogs of the Earth-Sun system, we know that there are billions of those analogs with an Earth-sized planet, roughly at the same separation from a sun-like star as the Earth is from the sun. Under similar circumstances, you might expect similar outcomes. And most of those stars are billions of years older than the sun. So there was plenty of time for things like us to exist in our past. I would call that an ordinary claim, to imagine something we already know exists and imagine it happening under similar circumstances again. And because it's an ordinary claim, we should just seek ordinary evidence for it. And that's the way science is done, by collecting evidence. But the claim that it's an extraordinary assumption to imagine something like us usually implies that we should not seek the evidence. So there is no federal funding right now for the search for technological signatures. There is actually the mainstream of the astronomy community is planning to invest more than $10 billion so that by the year 2040, we'll have a new space telescope called the Habitable World Observatory that would search for microbes, for the molecular fingerprints of microbes. Microbes, as far as I'm concerned, are much more boring. We should hedge our bets. We should, because in principle, if we find a technological gadget, it would be much more conclusive evidence. Molecules in the atmospheres of exoplanets could be produced by natural processes, some geological processes. And the one reason I seek a higher intelligence in interstellar space is because I do not find it here on Earth. Life is a self-fulfilling prophecy, so it's better to be an optimist. If you don't search, you will not find any evidence. And new scientific knowledge does not fall into our lap. We had to invest $10 billion in the Large Hadron Collider in order to find the Higgs boson. We haven't found the nature of most of the matter in the universe that is labeled dark matter. And the Webb telescope cost roughly $10 billion to find the very first generation of galaxies. So frontiers of science require billions of dollars. And right after the elections, Peter Thiel said that one should never bet against Elon Musk. And I saw around the same time Elon Musk saying, "Oh, we are probably alone. That's why we should go to Mars to preserve humanity." And so a day later, I placed a bet against Elon Musk because I believe that we are probably not alone. And to find out, I suggested that I put forward 1% of my net worth against 1% of his net worth, which is about $4 billion. And then for a decade, we can search for evidence. If we don't find anything, I'm willing to give him another 1% of my net worth. We currently spend $2.4 trillion every year on military budgets worldwide, a third of that in the US. And if we changed our priorities and decided to invest this much money in space exploration, we could in principle send the CubeSat towards every star in the Milky Way galaxy within this century. It's just a matter of priorities. And of course, if we know that we have a neighbor, that would motivate us to perhaps reach the neighbor's yard. We should hedge our bets, search for technological debris. But if I had to choose a destination within the solar system that I would like to visit, it would be Titan, a moon of Saturn, because it's the only object other than Earth that has liquids on its surface. It's much cooler than the Earth, about 94 degrees above absolute zero Kelvin. But it has liquids of methane and ethane. And what I would like to do there is to go fishing, because maybe there is something swimming in those oceans, lakes, or rivers of methane and ethane. If we find anything, it would be life as we don't know it, because Earth-based life involves chemistry in liquid water. There is actually a NASA mission that will go there in 2028. It's called Dragonfly. Now, closer to home, near Earth, there were 3 reports from the Director of National Intelligence to the US Congress in recent years, discussing unidentified anomalous phenomena. These are objects near Earth that are not well understood. In fact, I just spoke a couple of weeks ago with the new director of the All-Domain Anomaly Resolution Office. And they say most of the reports can be explained, but there is still a small fraction of them at the level of a few percent that they cannot explain in terms of human-made technologies, primarily because they don't have high-quality data. And so there is a need for scientific study of these objects. And this is what the Galileo Project is all about. I'm the head of that project. It was established almost 4 years ago. And we decided to build an observatory, or several of them, that we look at the sky at all times in the infrared, optical, radio, and audio. And so we have one functioning observatory at Harvard University that is collecting data on about 100,000 objects every month. We have already about 1 million objects that worth of data. We are analyzing it with machine learning software to figure out if there is anything unfamiliar, anything that doesn't look like a balloon, a drone, airplane, satellite, and that has unusual flight characteristics. Within the coming months, we plan to start doing triangulation, meaning that we will have sensors that are separated by about 10 kilometers from each other, so that we can figure out the distance of an object in the sky by looking at it from different directions. And that would allow us to measure the speed of an object. In addition, we are planning to build 2 new observatories, one in Pennsylvania and the other one in Nevada, by the summer of 2025. And then a fourth one in Indiana within a couple of years later in a STEM education center that is being constructed there. That would serve also for education of young scientists to make them excited about exploring the unknown. Now, from an astronomy point of view, not from the government point of view, there is a new frontier that was opened over the past decade. It's a frontier of interstellar objects. These are objects that came into the solar system from outside. How do we know? Because they move too fast to be bound by the sun's gravity. And therefore, they must have arrived from outside the solar system. The first one was actually identified back in 2014, more than a decade ago. It was a meteor, an object roughly half a meter in size that collided with Earth. And the fireball that it generated was spotted by US government satellites. It was moving faster than the escape speed from the solar system, and therefore it appeared to be interstellar in origin. And then in 2017, almost 4 years later, there was another object identified by a telescope in Hawaii called Pan-STARRS. This one did not collide with Earth. It was bigger than, or of the order of a football field, much bigger by a factor of 100 or so, 200 than the meteor. And it was recognized because of the reflection of sunlight from it. Both of these objects appear to be anomalous. The meteor had material strength that was tougher than all other meteorites that were cataloged by NASA over the past decade, hundreds of them. And moreover, it was moving at a speed that is higher than 95% of the stars in the vicinity of the sun. And the second object, which was given the name Oumuamua, meaning a scout in the Hawaiian language, because it was discovered in Hawaii, that object was anomalous because the amount of sunlight reflected from it changed by a factor of 10 as it was tumbling every 8 hours. And that implied that it has an extreme shape, most likely flat at the 90% confidence based on the reflection of sunlight. So it looked like a pancake. We did not observe, we did not image it, but that's the way that the modelers inferred its shape. Moreover, it was pushed away from the sun by some mysterious force without showing any sign of cometary evaporation. And the question was, what is pushing it? And then the third object is called is named after the amateur astronomer that discovered it, Borisov, and it was actually a comet, just like the comets that we are used to, except it came from outside the solar system. It was moving very fast. So some of my colleagues argued, well, it looks like only the first two are anomalous and the third one appears to be natural. Doesn't it convince you that the first two are natural as well? And I said, well, if you go down the street and you see a weird person, and after that you see a normal person, it doesn't make the weird person normal. And this is an artist's depiction of Oumuamua. It was thought by some to be cigar-shaped, but in fact, it was most likely the 91% confidence flat. I suggested that maybe it was pushed by reflecting sunlight because there was no evidence for a cometary tail. And in fact, 3 years later, there was another object found that was pushed by reflecting sunlight. It was given the name 2020 SO, and that one was actually a rocket booster from a 1966 launch by NASA. So here you have it, an example of a technological relic that we produced. The question is, who produced Oumuamua? I basically said, this comet, this is not a comet because it doesn't have a cometary tail. the emperor has no clothes. There is no gas around it. My colleagues, comet experts, argued, well, it has a tail, but the tail is not visible. The emperor has clothes. You just can't see them. And most recently, they argued that it may be a dark comet, meaning a comet where the tail is invisible, which is an oxymoron. So my proposal was it may be just an empty trash bag that is pushed by reflecting sunlight. It has to be very thin, or some broken piece of a megastructure like a Dyson sphere. But at any event, it's being pushed by reflecting sunlight, just like a light sail. We already know that we produced a lot of space trash. In fact, on January 2nd, this year, 2025, there was a report from an amateur astronomer about a near-Earth object, and the Minor Planet Center announced a new asteroid near Earth. It gave it a name. And then 17 hours later, the astronomers realized, oh, actually, the orbital parameters of this near-Earth object, match those of the Tesla Roadster car that was launched by SpaceX in 2018 as a dummy payload on the Falcon Heavy rocket. So this Tesla Roadster car is now on an elliptic orbit around the sun, and that was the near-Earth object that they thought was a rock. And then there is another object that was identified as a dark comet, and its orbital parameters are very similar to a Soviet spacecraft that was launched in 1965. And then, as I mentioned, in 2020, there was this upper stage of the Surveyor 2 lunar probe that was launched in 1966 by NASA and was at first identified as a dark comet that is pushed by sunlight. There are many examples of our own space trash that was thought to be rocks in space. And one should keep in mind that if an object exhibits non-gravitational acceleration without showing a cometary tail, it may not be a comet. So we should not classify it as a dark comet without a visible tail, for the same reason that koalas are not monkeys without a visible tail. They are just different animals. A spacecraft is a different object than a comet. About a year ago, I gave a talk at Torun in Poland, where Nicolaus Copernicus was born, and the Polish government invited me to give the public lecture, and I titled it "The Next Copernican Revolution," meaning that we might not be at the technological center of the universe. So not only that we are not at the physical center of the universe, we are also not at the technological center of the universe. What you see here is an actual real image of the Tesla Roadster car with the Earth in the background. And all I'm saying is that perhaps Elon Musk is not the most accomplished space entrepreneur since the Big Bang 13.8 billion years ago. There might be interstellar cars out there. In fact, there are about 1 million objects, roughly the size of a meter or so, within the orbit of the Earth around the sun. And we need to search for among them to see whether any of them that came from outside the solar system might be space trash of technological civilizations. I wrote a paper recently that shows that for that purpose, we can build a dedicated space telescope that will find the identity of these objects. Now, most stars formed billions of years before the sun, as I mentioned, and within 1 billion years, our own Voyager will be on the opposite side of the Milky Way galaxy relative to the sun. And so there was plenty of time for space trash from other civilizations to reach our backyard. Only over the past decade, we searched our backyard and found interstellar objects. So we might not have realized what we have out there. And if we have a tennis ball that was thrown by a neighbor, it will tell us that the neighbor plays tennis. So about 2 years ago, I decided to lead an expedition to the Pacific Ocean to search for the materials from the first recognized interstellar meteor. It exploded over the Pacific Ocean, and the US Space Command sent a letter to NASA after we identified this meteor in a NASA catalog with my student Amir Siraj. Their official letter confirmed that the object is interstellar in origin at the 99.999% confidence. And they also released the light curve of the fireball that had 3 flares separated by 0.2 of a second from each other. What was unusual is that the explosion occurred only 20 kilometers above the surface of the Pacific Ocean, meaning that the material had an unusual strength, tougher than all documented meteorites in that catalog of NASA. So here is the team that I recruited for the mission, and this is on the deck of the ship that we rented, called Silver Star. A very fitting name for that exploration, and it was made of aluminum. And behind the team, you can see this big structure that allowed us to connect a sled and carry it on the ocean floor. You can see the sled in the photo in the top middle and right-hand side. And so it was connected by a cable to a winch, and the cable was 5 kilometers long. We would place this sled on the ocean floor and drag it back and forth 26 times across a region that was roughly 7 miles in size, that was identified by the US government satellites as the location of the fireball explosion. This sled was covered with magnets, and the goal was to collect magnetic fragments from that explosion. What you see at the bottom left and middle is me jogging in the morning at sunrise. I did it every day as I do on land. And with me, there was a Netflix documentary team. And one morning, they decided to document my jog. And they asked me to jog 3 times as much as I usually do. So it took an hour and a half, and it was roughly a distance of 10 miles or so that I could monitor with my Apple Watch. And after I finished, the director asked me, Avi, it looks like you're running. Are you running away from something or towards something? And my reply was both. I'm running away from some of my colleagues who are not seeking evidence and have very strong opinions. And I'm running towards a higher intelligence in interstellar space. And so what we did is, as soon as we would bring the sled from the ocean floor to the deck, we would examine it for any material that is attached to the magnets, and then scrape the material off or use a vacuum cleaner to collect all the materials there, because the expedition cost $1.5 million for 2 weeks that we were there. And so every bit of material was very precious. And we would dry the material up and put it in vials. And at the end of the expedition, after the 2 weeks, I shipped the material in this black suitcase that you see on the right-hand side to my home, and then delivered it to the laboratory of my colleague at Harvard, Stein Jacobson, that you see standing here on the right, He has some of the best equipment in the world, including a mass spectrometer and also an electron microprobe that allowed him to examine those grains, the molten droplets that we brought. In fact, most of them were discovered by the person on the left in this image. She's Sophie Bergstrom, that was a summer intern with me when we came back, and she found altogether 850 molten droplets in the sample that we found. And they were very distinct, as you can see in this image, from the background sand. And she picked them up with tweezers. When we were on the ship, we only collected 50 of them because we didn't have time to go through the entire sample. And since she found most of them, I gave her the honorary title Spheral Hunter. So here are examples of the kind of spherules we found. Most of them, about 80%, were of a familiar type that we call primitive spherules. These are the type that you find in the solar system, either as a result of meteors from the solar system or geological activity on Earth. And we verified their identity based on their chemical composition. And then about 20% showed a very unusual chemical composition. We called it differentiated. Half of those had a chemical composition that was never reported before from solar system materials. So here are the results for 5 of those spherules superimposed. And what we are looking at is the abundance of various elements from the periodic table that are ordered based on volatility on the horizontal axis that you see at the bottom. The elements that are to the right are more volatile, so they can be lost in an explosion. And indeed, we are missing volatile elements for these spherules. But the most striking quality of these spherules is we normalize the abundances relative to the standard solar composition. And we found that some elements are up to 1,000 times more abundant in these spherules than in the standard solar composition, which is normalized to 1 here. Some of them reach a value of 1,000. And these are elements that are, for example, beryllium, lanthanum, and uranium. These are the most prominent outliers. And so we call these spherules Belau spherules for beryllium, lanthanum, uranium. And as far as we can tell, these are very anomalous, haven't seen before in any terrestrial materials or asteroids or the moon or Mars. And so potentially they could be candidates for interstellar material. And if so, that would be the first time that scientists put their hands on the making of a big object that came from outside the solar system. But to really figure out what this object was like, what the nature was, we're planning the next expedition. It will be more expensive, probably $6.5 million. And that would be to find bigger pieces of this meteor. And here you see me standing on the last day of the expedition alongside Art Wright. He was the party chief. In fact, you can read an essay that I wrote this morning about Art. It's in medium.com. If you search for Avi Loeb at medium.com, you can find all my essays. I write one every day or two. And today I dedicated my essay to Art Wright because I mentioned him in a class to first-year students at Harvard, at the Harvard College. And I did it on Monday. And I said that he represents or he epitomizes the opposite extreme to what you find on social media, in politics, or in academia these days, what most people do is what I call virtue signaling. They are trying to show off. And that is very clear when they are trying to show that they are good people by advocating ideas that they think are really important. But what they do is, for example, speak about how much they care about Black people or how much they care about Palestinians. But then they don't go to Black neighborhoods to actually help and promote the cause of helping Black people. They don't go to Gaza to help the people there. They just talk about it on campuses. And, that is exactly the opposite of Art Wright, because he was not saying much, but everything he said was insightful and in an attempt to solve problems that we had during the mission. And so he was completely oriented towards problem solving, not talking about the problem, but actually solving it. And he would solve it himself and would accompany that with words only if he thought that it's important for someone else to know about how he solved the problem. One example is we had the sled we wanted to keep it on the ocean floor, but it was not easy because when we attached a cable to it and pulled it, the flow of water under the sled lifted it like a kite. But within a day, Art Wright found a solution, put lead on the sled to increase its weight, increase the length of the cable to about 5 kilometers, which is very long, and moreover, pay attention to the ocean currents in terms of the direction that the ship is going. And problem was solved. Anyway, in this photo that you're seeing, I mean, I really admire Art. He's in his late 80s, was a commander of a destroyer during the Vietnam War. And in this, when we were looking at the sunset, we were planning the next expedition. And so we have everything ready. Right now, we identified a ship that you can see here on the top right. It's called Nautilus. Oops. And then it has a remotely operated vehicle, basically a robot that we plan to put on the ocean floor with a video feed so that we can see the pieces that we are picking up from the ocean floor. The only thing that we are missing right now, I mean, we have the team, we have the equipment, but we are missing the funding. It will be about $6.5 million for about a month worth of surveying the region with this robot. Another exciting development this year is the Rubin Observatory in Chile that will start operations in August this year, 2025. And it will survey the southern sky every 4 days. And it could detect an Oumuamua-like object every few months. It will employ a camera that has 3.2 gigapixels, about 1,000 times more pixels than your cell phone camera. And so it would be very exciting to find family members of Oumuamua, because now we could use the Webb telescope to observe them. We can get much more information about them. In fact, I just posted a scientific paper about how the Webb telescope will help us figure out the nature of Oumuamua-like objects yesterday. So I very much look forward to studying, analyzing the data from the Rubin Observatory in the coming year. And altogether, science is exciting, and this year I hope we will get new clues about the three interesting avenues that I mentioned. One is looking at the sky for unidentified anomalous objects using the Galileo Project Observatories, and we will have 2 new ones this year. The second approach is to look for interstellar meteors. If we get the funding of $6.5 million, we will go again and look for bigger pieces of this meteor. We have a second meteor that we would like to go to that was also interstellar. And finally, the Rubin Observatory may find many more Oumuamua-like objects. So stay tuned, and I'll be glad to answer any questions you have. Thank you.
Wonderful. Thank you so much. Yeah, if you have a question for Professor Loeb, go ahead and queue it up in the chat there, or feel free to hit the React button down there at the bottom of Zoom and raise your hand if you want to ask it live. But I'll kick it off. I have several. So um, the last thing I kind of heard about Oumuamua was that maybe it was a nitrogen iceberg that cleaved off of something and made its way here somehow. What's your
Right.
take on that explanation?
Yeah, so there were several other explanations as well. That the first one was that it's a hydrogen iceberg, meaning that it's made of hydrogen, and we have never seen a chunk of frozen hydrogen 100 meters in size. The only location that one can think of where it could be made are molecular clouds, but there is no evidence to support the formation of solid hydrogen of such a large size. Nevertheless, I wrote, after this was proposed, I wrote a paper with a colleague uh, uh, that demonstrated that such an object would evaporate along its way from a molecular cloud to the solar system by absorbing sunlight, simply because molecular hydrogen is very fragile. It's very easy to evaporate. And so the authors of that study agreed. And then there was another suggestion. Maybe it's a dust bunny, meaning a very fluffy cloud of dust that is 100 times less dense than air. And then it would be pushed by reflecting sunlight. The problem with that is that it won't maintain its integrity. Just imagine an object that is 100 times less dense than air. When it comes close to the sun, it will be heated by hundreds of degrees. So then another suggestion was made that maybe it's a nitrogen iceberg, because in that case as well, just like the hydrogen iceberg, you will get a cometary tail, but it might be invisible, because the only reason we see comets is their tail contain carbon-based molecules and dust that scatter sunlight, and we can easily see them. But if the object was made of hydrogen, pure hydrogen, or pure nitrogen, we might miss the cloud of gas that comes off it. And the problem with the nitrogen hypothesis is that there isn't enough solid nitrogen in the Milky Way to make a large enough population of Oumuamua-like objects so that one of them will cross the path of the Earth over the past 10 years. Even if so in the solar system, the only place is Pluto. The crust of Pluto has solid nitrogen, but they're just, if you imagine that every star has Pluto-like planets, and you just do the mass budget, there isn't enough mass in solid nitrogen to account for that, for what we saw. So, and then there was another suggestion, maybe, it's only the outer part that is hydrogen and the inner part is water, and simply the water molecules were broken into hydrogen, and we showed that the energy balance in that proposal missed a term that was a million times bigger than they considered. So actually, we don't think that is viable as well. So there are challenges to all these suggestions, and by the way, each of them describes an object of a type that we've never seen before. So why not leave the possibility that it was a thin object in the form of space trash, technological space trash, on the table? But nevertheless, if you ask any of those mainstream scientists, they would argue very strongly that we should not consider any other possibilities.
Mhm. Yeah, and I want to clarify your position there too. Like, you're not saying yes, this was an alien artifact. You're saying it could be. We can't rule that out, and maybe we should get more
Exactly.
data to figure it out, right?
Yeah, I think we should be curious to get more data, because I would love to have a flood of data so that nobody can dispute the fact that it's not a hydrogen iceberg. It's not but all we need is to collect that data. When this object passed near Earth, we got very limited data because everyone assumed that it's a rock of a type that we've seen before. And therefore, they didn't need to get very exquisite data. Now we know that we should be much more attentive to such an object. So my hope is there will be many more. And just like as in the case of Galileo, at the time the Church, the Vatican, could deny it, could argue, "Oh, we will put Galileo in house arrest. We will ban the Book of Copernicus," and they were successful for 350 years after Galileo died. But then in 1992, the Vatican said, oh, yeah, sorry, Galileo was right. We admit that. And that was 2 decades after humans reached the moon. Okay. So they arrived at the conclusion simply because it was beyond any reasonable doubt based on all the evidence that we have. And my point is, I would like to have as much evidence as possible because once we have that, nobody could object to the fact that it's not a hydrogen iceberg or that it's not a nitrogen iceberg, that it's something else.
Mhm. Absolutely. And I want to also talk about how this stuff gets here. So, given the vastness of space and time, it's highly unlikely that anybody aimed something our way, right? So, you're basically saying there's so much stuff out there that we're just kind of running across it, right?
Yeah, I'm saying within the orbit of the Earth around the sun, right now there are about 1 million interstellar objects, and let's just check if among the rocks there is any space trash, because the Voyager is moving at a speed that is more than 10 times smaller than the escape speed from the Milky Way galaxy. So any rockets that were launched by other civilizations over the past few billion years, they would still be trapped by gravity to the Milky Way. They would accumulate like plastics in the ocean. And so all we need to do is check our backyard, whether there is anything like those, the space trash that we produce, those objects that we know we are polluting the interstellar medium with. And that's just the way science is making discoveries, by exploring anomalies and looking for things that we haven't studied before. But if you already say that it's an extraordinary claim, therefore no money should be spent on this, you would never find, it's the best way to maintain your ignorance. You would never find anything without seeking it.
Mhm. And actually, I just read an article by Seth Shostak of the SETI Institute that was also a past guest of ours, basically agreeing with you, saying that these artifacts are long lived. You don't need to have that coincidence of time and space to be looking in the right direction to see a transmission. So maybe this is
Exactly.
actually a better idea, right?
Yeah, exactly. Traditionally, SETI was all about looking for radio signals, but that is just like waiting for a phone call at home. Nobody may call you when you're waiting. And if a signal passed by 1 million years ago, we were not around to detect it. However, as I mentioned, the technological objects are staying around. They're bound by gravity if they don't move too fast. If the escape speed from the Milky Way is 500 kilometers per second, and the fastest spacecraft that we produced is moving at 30 kilometers per second. So it's about uh, 15 times slower.
Mhm. Right. I want to make sure we get to some of our member questions here. Luke C asks, how confident are you that any of the yeah, that's a hard word to say, spherules you found in the ocean were part of that interstellar meteor?
I'm not entirely confident right now because all we have as of now is the chemical composition of those Belau spherules. But we are actually right now engaged in studying isotopes of strontium, for example, or neodymium. And these isotopes, for all the materials in the solar system, they have very characteristic abundance ratios. And for example, some isotopes never have an abundance ratio that is smaller than a certain value for all the solar system materials. So if we find isotopes with an abundance ratio that is completely outside the range within the solar system, this would be indisputable evidence that the material came from outside the solar system. Just having a chemical composition that is different, is not sufficient, because people argue, well, maybe, in some parts of the solar system that we never explored, you have those abundance patterns. But if we find isotopes with abundances that deviate from the entire range of solar system materials, you can't make those anywhere in the solar system, because isotopes are made in specific quantities as a result of either exploding stars or colliding neutron stars. And when you find an abundance ratio, it reflects what, the cloud of gas that made the solar system, for example, that had the same abundances. And if we find something that deviates from that, it means that it came from a completely different environment, another star far away. So that would be conclusive, and hopefully we'll know the answer on that within the coming 12 months, because we actually maybe 10 months, because we just started this study of the isotopes. We are hoping to get that information. So I will know more. I mean, my confidence will grow to almost certainty if we find the isotopes outside the range of solar system materials.
Great. Alexander asks, could AI help us recognize patterns or anomalies in interstellar data that humans might dismiss? And if so, are we already doing this in practice?
Well, definitely there could be things that we are not paying attention to. I should also say that technologies developed by civilizations that had more than 100 years of science and technology could look very different than our own technologies. They might be much more capable, and they could be stealth technologies that are difficult to detect. Just to give you an example, our most advanced technologies right now, for example, artificial intelligence, are based on chips that are the thickness of maybe 10 atoms or so, tens of atoms. And these technologies are based on our understanding of quantum mechanics, which was discovered just a century ago, 100 years ago. And if you imagine a science and technologies that are 1,000 years old, or maybe 1,000,000 years old, or 1,000,000,000 years old, we just cannot imagine what they might do. The example I usually give is the biblical story about Moses witnessing the burning bush that was never consumed. And that convinced Moses that there is a superhuman entity out there that he called God. But if we were to show Moses a cell phone that we have today, that he would have been even at more awe looking at this cell phone than at a burning bush. It's much more impressive than a burning bush if you look at a cell phone. And moreover, the cell phone has a GPS system that would have saved Moses 40 years walking in the desert and not finding the promised land. With a GPS system, Moses would have reached the promised land within a couple of weeks. So it would have had a practical benefit. And it's not a product of God or superhuman entity. It's a product of humans, just with better technology than Moses imagined. And so that's the experience we would have when encountering far more advanced technologies. We would be at awe. And it's quite possible that, there are things in the sky that we completely ignore that represent those technologies. And that's why I'm trying to look at anything that looks unfamiliar without assuming what it might be.
Right. There's also the idea that maybe ET is an AI, that, that's kind of the natural progression of a
Oh,
technological
yeah, no,
civilization.
that's for sure. I talk about that in my book Interstellar, and biological creatures like us they evolved to survive under the surface conditions on Earth, and the interstellar space is a very hostile environment because, well, first of all, the journeys take very long. Even at the speed of light, it would take tens of thousands of years to cross the disk of the Milky Way galaxy. So, and moreover, the human body will be exposed to hazardous cosmic rays, to very extreme conditions. So I think it makes much more sense for us, for example, to send AI astronauts. These are systems that benefit from AI. We haven't sent autonomous systems that have their own brain. All the systems we send to space, for example, the Perseverance rover on Mars, they get their guidance from engineers in the Jet Propulsion Lab in Pasadena. So I call that helicopter parenting of these engineers. I mean, actually, they parented a helicopter on Mars called the Ingenuity. But in the future, we might send systems equipped with AI. This is necessary when you send systems to destinations that are far away because the trip takes a long time and you need the systems to be autonomous. If they waited for guidance from the sender, they would have to wait a lot of time, thousands, tens of thousands of years to get a response. And also, it would require a huge amount of power to communicate with the sender. So I think of interstellar travel more like sending our kids out of home. Every now and then they might send a postcard, but pretty much they have their own brain and can function, make decisions on their own. And therefore, AI systems are very likely to arrive here more than biological creatures from another star.
Mhm. Great. A little bit off topic here, but something most astronomers have an opinion on. From Larissa Kivett, she asks, what is your opinion on the almost 12,000 satellites orbiting Earth? Are there any negative impacts? Will there ever be a limit to how many are launched? And in fact, we're about to launch a bunch more in 5 minutes here.
Well, definitely negative effect for astronomy. In fact, all these communication satellites, 6,000 of them from Starlink, behave like city lights in the sky because they are high enough to reflect sunlight. So what you see is, if you put a telescope that surveys the sky, like the Rubin Observatory, there will be a lot of streaks through the images that the Rubin Observatory gets that are associated with Starlink satellites. And obviously, along these streaks, the data will be obsolete. We won't be able to use it. And so usually, as you know, observatories go away, far away from cities because they don't want light pollution. And now these communication satellites are glowing in the night sky. So even if we go away from cities, we still have city lights in the sky. That's a problem for astronomy in the future. And in fact, I calculated a year ago that the Rubin Observatory can detect the sunlight reflected from a fragment that is as small as 10 centimeters. And there are plenty of those as a result of broken satellites that collided with each other, that had some catastrophic explosion or something bad happened to them. There are many tens of thousands of those, and there will be more because the more we put, the more satellites we put around the Earth, the more collisions there will be, and near misses, and it's a runaway process. Once you have a lot of fragments, the chance of additional collisions will grow. So that will be devastating for astronomy. We'll have to build telescopes on the moon, where you don't have right now a lot of satellites. Although once we do that, there will be satellites around the moon. Then we can put it on Mars until there are satellites around Mars. We can always put space telescopes, but they're much more expensive, usually by a factor of at least 10. So it's a serious issue for astronomy, and the commercial benefits from putting communication satellites means that these entities like SpaceX don't pay too much attention to astronomers.
Absolutely. Thank you. I think we have time for one more quick one. So, Luke
Mhm.
mentions you threw out an estimate of 1 million interstellar objects within Earth's orbit at one point.
Yes.
Where did that estimate come from? How did you get there?
Yeah, so it was based on the discovery of the interstellar meteor over a period of 1 decade. So if you take the cross-sectional area of the Earth and you just say the Earth is moving around the sun, what's the chance that it will hit one of those interstellar objects that are roughly half a meter to a meter in size? If in order to get that rate of a collision to be once per decade, you find that there should be 1 million of them within the orbit of the Earth around the sun. So the Earth is just colliding with a tiny fraction of them because of its small cross-sectional area relative to the area associated with the entire orbit of the Earth around the sun.
Right. Thank you. And we look forward to the next chapter of your explorations. And thank you so much for your time tonight. This was a great talk, so much appreciated.
Thanks for having me. It was a great pleasure, and don't hesitate to reach out. And you can find my essays on a daily basis on medium.com.
Yep,
Thank you.
avi-loeb.medium.com. Thank you so much. It's a pleasure. And Dave points out that the launch time for that next batch of satellites is now 7:40 p.m., so you won't have to watch my screen rattling right now. Yay. Thanks so much. And now I'm going to hand it over to our Vice President, Sharife Gacel, to take over the rest of the meeting because I have to skedaddle. Sharifa, you ready to go?
I'm ready to go. Ready to share
All
my screen and let's go. All right, so I'm
right.
gonna pick up right where we left off, and there we go. Should be good to go. All right, can you see my screen? Everything good?
You good?
Awesome, awesome, cool. Well, we are going to continue with club news, and what we have coming up. Let me move this over here. So we have Geneva Dark Sky Nights coming up, April 25th and 26th. So very excited about that. If you're a new member and you have not been out to Geneva, to the Dark Sky site, highly recommend it. It's a great time. They send out an email with all the information, how to get there and how to show up and everything to it. Bring your telescope. If you're learning how to use a telescope, you can learn from someone else, and come join us for that. And we also have the Orlando Museum of Art exhibit coming up on April 17th and 18th. So this is very exciting. A lot of astrophotography pieces that'll be on display at the Orlando Museum of Art. And it'll be free for CFAS members. It's on the 17th and 18th, which I believe is a Thursday and a Friday. Stay tuned for emails and information about that from Isabel, our events chair. A lot of cool information, really neat event to join with that. Our next in-person meeting, as a reminder, will be June 28th at the Planetarium. It'll be at 6 p.m. And Derek Dember, who is currently in Italy, will be talking about his trip to all around Italy and his astro adventures and what he's doing there, projects, teaching, a lot of really, really cool stuff coming up, and also astronomy down under. And then we'll also have some breakout rooms, specifics of that to be determined and will be announced soon. And then before that, we have a Zoom meeting. We have May 14th, we have Emily Levesque, who will be our guest speaker. So also very interesting speaker and presentation. Our Loaner Scope program, if you are a new member or you're interested in borrowing or one of our telescopes, that's one of the really cool perks of CFAS. Or even if you've been a member and you don't have a telescope yet, we have our Loaner Scope program, and we have a ton of telescopes that you can rent out basically for no charge if you're a member. And working on getting a C-Star out in a remote observatory location currently, and some very exciting plans with that. And the board has been working very, very diligently with that. And also a huge thanks to Christopher Hunt, our Loaner Scope program coordinator, for kind of spearheading this project. If you do want to borrow a telescope from our Loaner Scope program, feel free to reach out to Chris at loaners@cfas.org. So welcome new members. If you have joined and you're new, make sure that you check out your email that you would have received with welcome to the Central Florida Astronomical Society. And it would be an email that outlines everything on how to get access to our group's IO chat. We have the main chat that we have in the group conversation with that, with all the announcements of meetings and any kind of outreach or anything. We also have some tabs, some subgroups. If you're ever interested in joining some outreach programs, we have that. That you can join also in different events. We have a C-Star sub-community if you're interested in joining that. So explains any members' benefits that you might have. And if you have any questions, please feel free to reach out to our board members at large, Wes Clem at bmal1@cfas.org, or John Pizzo, bmal2@cfas.org, or our president, Frank Kane, president@cfas.org, with any questions about being a new member. So the CFAS board needs you. We're still looking for a publicity chair and an education chair. The real nuts and bolts of it, the publicity chair will be looking to kind of help promote our events and what we have and the different programming, everything with CFAS, and that could be either on social media or in different kinds of media. So if you are interested, please feel free to reach out. And also an education chair. So if you don't want to commit to one of the bigger positions, you can also serve on a committee. And we have different subcommittees for different events, for outreach, for loanerscope, for treasury, for anything that you can think of. And if there is something that you can think of in addition to that, we're always looking for help with and ideas for events, programming, outreach, loaner scope program, treasure, kind of science ideas, website membership, or make your own. We're open to hearing your suggestions. And if you have any suggestions for programming, if you want to hear any kind of speakers or any kind of topic specifically, please feel free to reach out to me at vp@cfas.org. I'd love to hear your ideas. If you are already a member and you have a really, really neat idea or just even something that you're interested in, a passion project, whatever you got going on, feel free to reach out, and we would love to have you speak at one of our meetings or maybe do a mini program or one of our breakout rooms in the in-person meeting. So we are going to be, talking about the deductible donations, tax deductible donations. CFAS is a 501c3 organization, so just a reminder for that. And we're always looking for sponsorships and corporate donations. If you have any ideas, feel free to reach out. John Frank has been leading a new fundraising initiative, which has been fantastic. Have a lot of really exciting stuff going on in that regard, and also with a lot of new members that are joining. So we're also in cyber grants, which is matching donations from Disney and other employers. So if that is applicable to you, or you know of anyone that that might be able to have any ideas with that, feel free to reach out. So upcoming astronomical events. So we have some fun stuff coming up. It is now galaxy season. So if you haven't gotten a chance to look through your telescopes or image or whatever it is, now is galaxy season, as many of you might know. We have a surprise comet, Swan, which I just heard of, yesterday, I believe, was the first time. And so it's currently going to be showing up in the morning. So about an hour or so before sunrise at about 5:45 a.m. And it'll be in like east-northeast direction in Pegasus at about 10 degrees elevation. Stay tuned for more information about this comet. It'll be getting brighter and brighter, and then eventually it'll be visible only in the southern hemisphere. So later on April 12th, we have the full moon and Spica, which rise together, and that'll be really neat to see. Maybe again, do imaging or any kind of visual astronomy with it, see them kind of rising right next to each other. April 21st through 22nd, we have the Lyrid meteor shower. Little tricky to see because the moonlight will make it suboptimal viewing conditions, but still keep an eye out, never know. And then April 24th, Venus will be at its brightest. So take a look out at the night sky and you'll see the brightest object, which will be Venus at that point. And on April 25th at dawn, we have Moon, Venus, and Saturn all in a triangle, which will be pretty neat to see. And then in between there, we'll be at Geneva dark sky site and then the new moon. So it'll be great for viewing out in Geneva. So I hope you will join us for that. So we're going to be moving to the astrophotography and sketching showcase. So if you are on the meeting, if you're in the Zoom meeting, and I come to your picture, feel free to unmute yourself and share a little bit about your image. If you're not in the Zoom, that's okay too. I have the information that you might have sent, and we will get on with that. So first up, we have Bill Castro. I did not see you, Bill, in the meeting, but if you are here, feel free to unmute yourself. And here is Bill's image. Bill, are you there? No. All right. So the image, the details that I have on that is from the lunar eclipse that he took this picture from iPhone 12 Pro using a 92 millimeter stowaway refractor telescope, an 8 millimeter radian eyepiece at 76x, Skyview Pro mount, like I said, on his iPhone 12 Pro, and a Celestron Next YZ 3-axis smartphone adapter. For that, this was taken on the 14th of March at 2:59 a.m. from OBO at approximately 28.67 degrees north, 81.19 degrees west, and the image is unenhanced. So it's a fantastic picture of the eclipse. Next up, we have Frank. Frank, you still on? Maybe not. All right, so this one is an incredible image of the Dolphin Head Nebula that he shared, and just it's mind-boggling. I believe this one might be one of the images that's enlarged for the Orlando Museum of Art showcase. So this, along with a lot of incredible images from our members. So go check it out. This one, the information that I have from it is basically it's a bubble of gas about 60 light years across, and it's blown out by a really hot star at its center named EZ Canis Majoris. Incredible photo of Dolphin Head. Next up, also from Frank Kane, we have the Antenna Galaxies. You're looking at an image of two galaxies in the process of merging together in the constellation of Corvus, and it's about 45 million light years away. All right, so we have Pete Lefebvre. If you are in the Zoom, feel free to unmute yourself, and here is your image. Pete, are you there?
Yeah, this is Pete. I'm actually here.
All right.
I wanted to send this just, I recently bought a Sea Star and joined the club. So instead of trying it on a bunch of different objects, I just spent 3 weeks focused on M42 and, how to stack the images, how to edit them. And so it's a lot of fun and keeping at it. Gonna figure out the next, looking forward to Galaxy season. Thanks.
Awesome. Are you liking the S50 so far? Having fun with it?
So far so good.
Yeah.
It seems a real capable piece of equipment.
Yeah, for sure. Awesome. Well, thank you for sharing this beautiful image. And next we have Jeff Merrick. If you are in the meeting, feel free to unmute yourself.
I'm here.
This is you.
This is the ICE Galaxy. Galaxy is also known as Op 120. And it's it's a pair of interacting galaxies located about 50 to 60 million light years at a magnitude about 10. It's part of the Markarian chain of galaxies, so there's lots of galaxies in this, right nearby. So if you're going to look for galaxies, this is the location to do it. And let's see, in this image I used 88 subs at 2 minutes for a total time of 2 hours and 56 minutes using my 190 millimeter Matnu telescope.
Awesome. It's beautiful. Okay. Yeah, thank you for sharing. Next up, we have Cal Beard. If you are on, I believe I saw you earlier.
Hello, can you hear me?
I can.
All right. Well, I do a lot of comet hunting. When I take a picture of a 13 or 14th magnitude comet, it is just not real fascinating to anybody. So I take other pictures while I'm having fun. And of course, M87 is the one that has the jet coming from the super dense black hole in the center of the galaxy. Put an insert up there of what the jet is theoretically supposed to look like, and the bottom insert is what Hubble sees it, and the center is what my Sea Star was able to take a picture of.
Very cool. Made a note to go image that myself at some point. And next we have this on the Owl Nebula.
That came out so cool.
I know. Tell us a little bit about it.
I was at the Chiefland Starfest and took some pictures, and this one I took after I got back to Leesburg. The one I took out there didn't come out as good, but this one I was amazed to see how clear that was after just an hour and a half on my Sea Star.
Yeah, you definitely see the eyes very well. Yeah. Awesome. Very cool. Thank you. And this one.
And one more. I'd not seen many pictures that really looked like a head or a simian face in the picture, but this one came out looking a lot like a nose and a chin and a mouth on this monkey head cluster. So I was pretty excited to see that.
Awesome. Also at Chiefland, see Leesburg.
That was just Leesburg, not Chiefland.
Leesburg, okay.
Awesome. On my front porch.
Yeah. Very cool. Well, thank you. Awesome. And next up, we have John Starr. I think I saw you also. Spectacular image of.
Yeah, good evening. This is sort of the Pi Day eclipse, and this is just a simple composite over the or I guess early morning hours. And so this was just a Canon EOS RA on a Star Adventure star tracker with a Sigma 150 to 600 at 600 at f8. And so it was really easy to take because I was cheating because it was on a star tracker. So I just set it the intervalometer just to take a shot, every few minutes. But what was really hard is throughout the evening, I think most folks that tried to shoot the eclipse was the settings on your camera that you would need to change as it would get very dim throughout the evening. And so I really struggled with that, but I was able to sort of match the brightness for the most part during post. So I just kind of put the images together to show the progression while keeping the moon's orientation the same.
Well, that's definitely something I wouldn't have thought of until I was doing it and then realizing what was happening. So appreciate you sharing that. Yeah, beautiful image. And next up we have Wes, and I believe Wes is not with us today. So have this incredible image that he shared, and this is the Witch Head Nebula with Rigel over on the right-hand side. And this is a spectacular image. Can't quite zoom in here, but I think this one might be also at the Orlando Museum of Art. And if you get a chance to see it larger, the detail on this is incredible. I want to say that he also won the ZWO Astronomy Picture of the Week with this image, and it's about 12 hours of LRGB on his Red Cat 51 with 294 millimeter probe on a wave 150i from WSP from the Winter Star Party. So incredible image. And last up we have John Pinto. So John, share this info on this awesome picture. John Pinto, are you there? Maybe. John? No? All right. Well, this is a image. I don't know exactly the details on it. You can see some of it on the bottom, but I know he took this with his obviously C-Star S50, and this is with a newer filter that he was able to get for the S50. It was something that not the standard one that came with the C-Star, but something else. And again, you can kind of not quite zoom in on this zoom, but if you see it in a different context, you get really neat detail on the sunspots and some of the other areas on it. So that wraps it up for us. So I'm going to stop sharing my screen. There we go. Cool. Well, I just want to thank everyone for who joined us live, and we'll have the YouTube recording for anyone that couldn't join us live that want to tune in later on. We'll share an email as to when that'll be posted. Anything else that we have coming up, stay tuned for Groups IO for any updates and events coming up. Hope to see you on May 14th in Zoom and in person on June 28th and also at Geneva. So thank you everyone for joining and for your astro photos, and have a fantastic night. I'm gonna end recording and